So first of all, though, while I'm the one giving the talk today, I am, of course, merely representing the Center for Computational Science. The center is a fairly unique thing within the University of Miami. As you can see, we have a number of different focus areas that we work with. Every single one of these is led by a senior faculty member who actually works for the center as well. So we've actually made an investment in this to make sure that we're actually directly embedded with the research community. My group, the Advanced Computing Group, is on the bottom, and along with software engineering and outreach, we work with the groups to access all of the resources we have at the University of Miami. As I said, I'm fortunate enough to lead the Advanced Computing Group, and we have a motto of follow the data. We're a little bit different than a traditional computational group. We're split into 3 different focus areas: big data analytics, high-performance computing operations, and cloud services. Our systems right now that we have, just so everyone has an idea of what we're talking about, is the Pegasus supercomputing cluster, about 10,000 cores, Jabberwocky, 1,000 core visualization cluster, Vault, a couple hundred core secure processing environment, and most importantly and relevant to this discussion, Wade, which is our worldwide storage cloud, which is currently at about 8.5 petabytes right now that we're serving out. That's active data. We don't maintain archive data within our group. And then finally, we have had our big data analytics infrastructure, Bigfoot. And I'll explain why I kind of use the past tense with that in a minute. About 2-3 years ago, I was asked to address the DDN storage group because we had what we thought was a fairly unique design. Instead of having storage kept local with the servers, we were going to make storage put in the middle of our design. So all of our different supercomputers, our different clients, our different customers, regardless of where they were, would be able to access the same data at the same place. This actually turned out to be a fantastic thing for us, and it really helped spur our growth. As you can see, about 3 years ago, we were only at about 2.5 petabytes of usable space, and now we're actually upwards of 8.5 petabytes of actual data that we're using. So we've, like I'm sure a lot of you have undergone a tremendous data growth in the last couple of years. About the same time that I was asked to speak at the DDN User Group, I was also involved in a project called the Long-Term Ecological Research Network. This project was a really fun one. I worked with Paul a little bit and George Jones as well to try and get some storage set so that we could take sounds from the Florida Everglades and analyze them. Okay? So what we would do is we would take these recordings and we'd transmit them via RF communications from self-sustained weather stations. It was a very bad kludge, but it did work. We were able to get lots of great data, and we were able to follow on with lots of different grants with that. My boss came to me after we completed this, and he said, you know, I've got a colleague over in biology, of all places, who's looking for a particular bird. You've done a little bit of work with audio this time. What I'd like you to do is go out to the Arboretum and start recording what's out there. And then I want you to be able to tell me whether you can find a particular bird. And I looked at him and I said, boss, this is an incredibly noisy environment. We don't know what we're dealing with here. We've never done anything like this before. How are we going to do this? And he looks at me and says, you worry too much. They have funding. Okay, I said. Next thing I know, I'm building an interesting sound detector. And once again, I said unfortunately, truly, this is my team. I'm responsible for the 3 groups you saw. All together, we form a research team as well, and we go out and we do this. My high-performance computing group said, well, this shouldn't be too bad. We should develop a background noise level, and then we should be able to just take a simple FFTW, a fast Fourier transform, and take a look for the different peaks that we see. If we isolate the frequencies, maybe we'll find the birds. Okay, I said, we've got a big supercomputer. We should be able to do this. Let's give it a shot. So, sure enough, we went through it, and wouldn't you know, with the help of the recording units, my home department of music engineering and what have you, we were actually able to go out and to record bird sounds, and son of a gun if we didn't find the northern mockingbird, a bird which had not been seen in Florida for over 30 years. Okay? Everyone thought it was extinct, it had gone away. We actually were able to find out where it was, they were able to see it, and they made a confirmation for it. So that all worked out beautifully for it. Hooray! Okay? My boss comes to me and says, well, you did great on that one. I got another challenge for you. He said, the city of Coral Gables is complaining that a new traffic circle we put in is creating noise for their residents. And anyone who's ever been at the University of Miami before knows that Coral Gables and the university, well, we're uncomfortable neighbors, and we'll leave it at that. So my boss came to me and said, we want you to do a study, record everything that's on there, and I want you to tell me where the sound is coming from. And I said, okay. We've never done anything like this before. How are we going to do it? He said, again, you worry too much. They have money. Just take care of it. All right, fine. I go to my group once again, and they say, well, this time I think we can do it, but we need to be able to stream the data. Okay? We can't just take, as we were beforehand, recording data and do it, move it over. We had to stream it. And at this point, we had to invent a little bit of technology. Number one, we had to invent a listening box for this. Okay? We had to say, how are we going to transmit this data across? How are we actually going to get it so they can write to what we're doing right now? The beautiful part about all this is that while we're doing this previously, everything was writing to our DDN storage. We had no problem with anything. My big data analytics group comes to me and says, this one's not going to work on a high-performance computing system. We need to bring in big data analytics for this. This is MapReduce. We need to take a look at what everybody's doing, and we'd be able to reduce the frequencies down and see what's going on. OK, I said, let's give it a shot. You guys know what they're doing. So we went out, and we got a big data system, got a little cluster for it, and it worked fairly well. It was quite good. It would ingest the Internet of Things data. It would analyze it while it was streaming at the same time, and we could actually provide user interfaces for our group. If you look back here, you can see where we have all of our applications up on top that our users would actually use for analysis, and we were actually able to feed it out from this big data solution. Okay? All was wonderful, all was happy. In fact, we found out that no, it wasn't the university. There was some unauthorized construction going on in Coral Gables about a half-mile away where they were using jackhammers. And this was disturbing the residents. We were actually able, through our sensors, to be able to show this to the city of Coral Gables and said, you know, maybe you want to take a look at this. Well, as it turns out, the city of Coral Gables was very, very happy with us because we got them lots of fines for the contractor. The university was happy, said, go on, let's see what else you can do. Okay. So now they come to me and say, you were so good with the traffic noise, we have student noise. And we need you to figure out what's going on with the student noise. Folks, I'm a director of advanced computing, okay? But this works. So we go on and we say, we're going to do this. So we go to the 6 different residence halls that are there. We're going to set up everything for it. We got our recorders set up just like we did everything beforehand. And the administration comes in and says, whoa, stop. So what's wrong? I said, you can't record anything. This is students. They have PII. FERPA says you can't record a darn thing. And I said, okay. And I went back to my team and my boss and I said, well, now we got a challenge. We got no power. We've got very little cost that we can put into this, and we can't record anything. What are we going to do? Well, this time, unfortunately, there was no money for it. So my boss said, you'll figure something out. Sure enough, I go to my group, and they say, well, you know, noise is really just sound power. It really doesn't have anything to do with frequency distribution. So what we could do is we could take our sound power levels, and we could measure them. Take a second derivative of that, move on, and we should be OK with it. I said, that sounds great. How are we going to move everything down now? My group came back and said, well, that's not too tough. We just needed something where we can broadcast the data. So we're no longer doing individual sensors. Now we have a broadcast node where we're building an ad hoc network to actually transmit all the data back. It worked. What can I tell you? 45% of the complaints were validated on campus, 65% of them were validated off campus. Needless to say, it led to a couple of changes in university policies, some administrative changes, some educational programs, and some more outreach to the community, which in this case was Coral Gables. Anyways, so after this, we saw that it did work. And here's where some things took a really odd turn for me. After this, I was approached by my boss and the dean of the School of Architecture and said to me, what do you know about smart cities? I said, I don't know a darn thing about smart cities. They said, that's great. We want you to design the network for it. We have a networking group. Can't they do it? Yeah, but you've been so good with the other stuff. Let's just give it a shot. All right. I went in and I took a look at it. Well, luckily, I contacted my networking group. They were kind enough to work with me on this. I gave it over to them. They said, this is fantastic. Now we want you to do the Internet of Things design for us. OK, went back, called a couple of researchers, and pretty much you can see what happened as we're going down the list. By the time this was done, anything that had to do with computation, networks, or what have you, my group was doing. Okay? And if you take a look at this, we actually were able to set everything up with 3 design studios. Okay? We weren't able to do any of this in-house. Okay? Too much for us to do. So what we did do, however, is reach out to our colleagues globally and said, hey, we want to set up an architectural studio with you where all our data is going to be worldwide and we're going to be able to access everything. Well, luckily, we're running the DDN, so it didn't matter to us whether we were running web traffic, high-performance traffic, or what have you. Everything went perfectly with it. Okay? We were able to stream our data through AutoCAD 3D to 4 different architectural studios around the world. We've done a visualization wall thing where we can actually distribute and show all the data that we're doing for this design, all off the same storage for it. It was a huge hit. We went to a couple of shows around the world for it, and if you're interested in what the smart city development is being done like, it's at that link at the bottom right there. While we're doing this project, however, my boss comes to me and says, I had a great meeting with someone down in Yucatan where we're building the city. I said, oh? He said, yeah. They got a problem with buses. I said, oh? He said, yes. They want to track where all the buses in the Yucatan Peninsula in Mexico are going. Okay, what are we going to do? He says, well, it's not too bad. All the buses have GPS in them. You should be able to handle all that. Okay, we can probably do that. He said, there's also an app, so you can take the geolocation data and all that from the app that people are using and find out where the riders are. Okay, that sounds pretty good. We can do that too. He said, but by the way, it's not just public buses, it's private buses. So once again, you can't record a thing on any of these things. All right, we know this routine. We know what we're doing right now. And he said, we want the analytics to be real time. This can't be a Hadoop system now where you're going to load the data up, query it, run iterations over it 1,000 times, get your converged solution, and serve it out to the user. This is for a bus. It's coming right now. So I went to my boss and said, I'm not sure we can do it. He says, of course you can do it. They have funding. So all you're going to do is build a decision support system for us. Okay, I went with my team, and not only were we able to build in a rules-based network so that we could actually do all of this stuff, we were actually starting to take a little bit of machine learning and artificial intelligence and apply it. Okay? We were starting to be able to tell when buses were going to come. We were also able to tell how we were dealing with this massive amounts of data and how we were going to put everything into the big data system. And I said, this is great. Everything's going to work fantastically. Until my big data group comes to me and says, it's not working. Okay, I've got a contract on the line. My big data group is collapsing for me. What the heck am I going to do? Well, luckily, I have Paul Block's cell phone number and George Jones's cell phone number. I called them up and I said, I'm in a predicament. I don't know what to do. What are we going to do? They said, well, just use the storage that you have. I said, we can sell you some more of the fast stuff. That's all you need. I said, what are you talking about? They came to me and they said, you know, you don't need to do Hadoop with analytics anymore. And I said, no, I had no idea. I thought we still had to run off our big data system. They said, nope. Everything can be integrated on your own DDN solution. I said, well, that's interesting. Let's try it. And we did. And sure enough, we found out with the map-produced meta blocks that are put inside of GPFS and running on the DDN hardware, we found that son of a gun, we were getting faster turnaround with our high-performance DDN solution on our Pegasus system than we were with the dedicated big data cluster. And this had nothing to do with the processing. This is all I/O bottleneck, no matter what we did. And so sure enough, after about 6 months' worth of work, we were able to work with our colleagues over in computer science, and we came up with some fantastic algorithms that were able to do breast prediction. Well, we were able to tell it within half of the time, within 1 minute, when a bus was going to get there. You gave us 5 minutes, we could get up to 90% with that. But what was more important for us than this is that these analytics were actually turning around in real time, and we were able to help them with bus routing and actually for them to send supplemental vehicles when they needed to do it. Their ridership has increased 30%, which isn't what they necessarily wanted, but they're seeing a much greater efficiency right now out of their buses. So we presented this in a conference, in a Smart Cities conference that we had with this, and all of a sudden, I was approached by the city of Miami Beach. They said, we love what you're doing. This is fantastic, but we got a real problem, and we don't know how to solve it. Okay, what's the problem? I said, we don't know where people are going on Miami Beach. I said, well, that's odd. How can you not know? He said, well, we got no way to tell. We have millions of pedestrians that come in every year, and we have no idea where they walk in the city. Buses, same story. Bicycles, the same thing. So no matter what they were doing, they could not tell where the city was going. So I talked with them, and I understood a little bit about their short-term goals. They really wanted stuff for emergency response, traffic control, as I had mentioned, but also they wanted it for city planning. And this meant that not only did we have to accept all this data, but we had to take it for long term. So I went to my team, and I went to my boss, and I said, well, we've got a challenge this time. There's no network. There's no power. The sites are completely exposed and everything. I said, but they have funding. So we're going to do this time. My boss said, OK, what are you going to do? And I said, well, this time, we're building a sound classifier. Okay? So with this point, we actually took our step even a step further. And we said, no longer are we just going to be recording sound. We're actually going to be taking AI, and we're going to be comparing sounds, and we're going to be teaching the city of Miami Beach to listen for the first time ever. Okay? By using spectrograph pattern matching, we tried a little bit with Theano. It didn't work particularly well for what we were doing. We really needed much more of the cafe recursive neural network to do it because it was not tabular data. But once we were able to do this, we figured out, yes, we can make this work. But now all of a sudden, we're no longer providing 50 sensors. We're not providing 100 sensors. We're providing close to 1,000 of them. And this was just a scale we weren't used to know what to do with. So my team and I sat down. My engineering team looked at me and said, well, this isn't going to be too bad. We're going to set up an Echolite sensor array. This array is going to be able to deploy it anywhere. You don't need to worry about it. I said, this is fantastic. This is wonderful. Let me take this back to the computing team and see what they say about it. I took it back to my analytics team, and they said, well, everything we've done beforehand, throw it out the window. Not going to work anymore. Too big. So what we've done this time, however, is that we scaled everything within our same storage. So we didn't have to worry about data migration and how we were going to move everything. Everything was working great until our listeners, which were a little piece of software deployed on a cloud thing, stopped working. I said, what's wrong? There can't be contention here. No, it's an object store. We have to go out to the web. We need to get everything. We need to bring it back in. We need to download the data, and it's a mess. I turned to my storage guy, and I said, this can't be. What are we going to do about this? And he said, well, we have the solution. He said, the best part is we don't even need to do anything. All we got to do is turn it on. I said, what are you talking about? He said, did you know GPFS has an object layer on it? I said, no, I didn't. He said, did you know we can actually use the data SSDs that we have for the metadata right now and move data around with them? I said, no, I didn't. He said, what about the disk pools and the file sets we can use? We can move all of this all over the place, and you don't have to worry about things. And I didn't know that either. He said, what about LSF and GPFS integration? At this point, I don't even know why I'm his boss anymore. But anyways, we get everything moving along, and everything works perfectly. And all of a sudden, we've got it. We've got a single data point. I can enter it from anywhere in the world. I can read out from it in anywhere in the world. And it's on one piece of hardware. I don't need to reinvent the wheel. I don't need to move data around. That's all done. So, as always, what are our results from this? Well, we integrated a people counter. We were able to tell where people were moving across the city of Miami Beach. And an interesting note, we were actually able to tell when a main pump failed during a major tropical storm that we had. We were able to notify the city. They went out. They put emergency measures on. They claimed we saved probably $1 million. Saying, well, that's nice for it. We've also done public disturbances. Most recently, I don't know how many of you read, there's a spring break week in the city of Miami Beach. Is anyone familiar with that? Well, last year there was a bit of a problem where they had 50,000 people that they were not expecting moved across the city from one beach to another beach, and they had no services there for them. Well, this year, we were able to predict ahead of time. We told them, well, you know you're going to need services over there. They said, well, what if they don't move there? I said, well, we'll tell you when they do. And sure enough, the minute they started moving across, we saw the sound. Moving across the city, we called them, moved the police over there, moved everything over there, no incidents for the rest of spring break week. So we count that as a win as well. But then, all of a sudden, the hurricane hit. Now, I'm sure you're all familiar with what happened with Florida, with Irma. And, well, we're back to the drawing board pretty much because it turns out sensors don't work too well at about 120 miles an hour. So, if anyone is curious, however, I have excellent recordings of what a Category 2 hurricane sounds like when it hits high rises. So you just let me know if anyone wants that. But it was a success, and after working with the city of Miami Beach, we are, in fact, moving forward with this project. We lost about half of it, but they're going to be replacing it with us. And just to finish up, I was approached by a friend of mine not that long ago, and he said to me, have you ever thought about working with chickens? And I looked at him, I said, no. I can't say that thought had ever occurred to me in my life. And he said, well, you should. He said, as it turns out, chicken farmers are very sophisticated, but they don't have anything automated. And they're very, very intelligent when it comes to taking care of their birds. He said, even with a free-range chicken society, you have to know your flock. You have to be able to count them. You have to find out where they're going and how they're growing. For him, he said, it's a huge problem. So I told my boss this, and my boss said, well, this sounds fascinating. Turns out I know someone in Tyson. I looked at him and I said, shoot, maybe I shouldn't have brought this up. And he said, that's okay, don't worry about it. They have funding. So long story short, over the last 3 years, this is where we've grown to. So from about 2.5 petabytes of available space, we've, as I said, I don't want to keep hitting these numbers, but take a look at the areas we're able to serve now. Instead of being very focused within our university and within our place, we're able to go across the world. Whether it's in Mexico for our smart cities and our bus projects, whether it's going from our sustained wave tank, which we use for climate change, or as I said, maybe even a chicken farm in North Carolina. But I have to tell you, the one thing we couldn't do it on is if we didn't have the storage from DDN. Thank you.